Hi everyone! In today's video, we're going to be expanding our understanding of the converse of Pythagorean theorem, essentially asking the question, is this a right-angled triangle? So we've already learned that Pythagoras' theorem states that if we have a right-angled triangle, we can find the length of a missing side by using a squared plus b squared is equal to c squared. Now, we can also use Pythagoras' theorem to prove if we have a triangle to figure out if it is right-angled. So if we have this equation, a squared plus b squared is equal to c squared, and both sides of the equation are equal, and the equation is a true equation, and we use our happy face, remember, then we can tell that this is a right-angled triangle. So let's take a look at our first example. What we want to do is we want to identify whether or not this triangle is a right angle. So now, even though we see in this picture that it looks like a right angle, we can't assume that it's a right angle unless we actually see the little square here indicating that it is a right angle. So what we can do is we can use Pythagoras' theorem to identify whether or not this is a right angled triangle. So we can write our formula down that we have a squared plus b squared is equal to c squared. And we're going to substitute the values inside of our formula, making sure that c is the longer side, always, because it's the hypotenuse. So in our case then, the 41 has to be the c. And then a and b doesn't matter, so we can do 9 squared plus 40 squared. Now 9 squared is 81. 40 squared is 1600, and 41 squared is 1681. So now we have to sum 81 plus 1600, and it does give us 1681, and we get 1681 is equal to 1681. Both sides of the equation are true. We are happy. This tells us that this actually is a right-angled triangle, so we could now put in the little box to indicate that. So let's take a moment to pause the video to try this first question out. We want to tell whether or not this triangle here with the given lengths of 28 inches, 21 inches, and 20 inches is a right-angled triangle. Now remember, the hypotenuse has to be the longest side. So now let's take a look at part B of our first example. Here we have a triangle that has measures of 18, 12, and 24, and we want to determine whether or not this actually is a right-angled triangle. So again, we can start off with our equation. So we have a squared plus b squared is equal to c squared. And then from here, we want to substitute our values, making sure that c is the longest side. So the longest side in our triangle here is 24, so the 24 must go here for c. And then a and b doesn't matter, so I'm going to do 18 squared plus 12 squared. So now what we can do is figure out what 18 squared is. 18 squared is 324, 12 squared is 144, and 24 squared is 576. So now we have to sum 324 plus 144 and figure out whether or not it is equal to 576. So 324 plus 144 gives us 468, and then I get my equation that says 468 is equal to 576. Now, we know that this is not true, so we'll put our little sad face. This is a false statement, so therefore, it's not right angled. So here's your second try question for this video, so take a moment to pause the video and figure out whether or not this triangle will be right angled. In our second example, we want to find out if these 3 points form a right angled triangle. So ideally, it would be a lot easier if we had these 3 points on a coordinate plane. But unfortunately, sometimes we're not always going to have a coordinate plane. So what we can do though is we could imagine we had the coordinate plane and kind of draw our points A, B, and C where they may be if they were on a coordinate plane. So I'm going to put my A right here. So I'll label this A as 1 and 1. and then I'm going to put my B. Now my B's coordinates is 3 and 5, which means that it's going to be more to the right than my point A and more up than my point A. So I'm going to put my point B just maybe about here and label this B and 3 and 5. Now I'm going to label C. Now what it's good to notice is that my C and my B, they both have the same x coordinate. And if they have the same x coordinate, that means that they are vertically on top of each other, right? If they were on a coordinate plane. So I can now draw like kind of like going straight down from my B and put my C. But it has to be a little bit lower than my A because the y coordinates, A's coordinate of the y is 1 and C's coordinate is 0. So it's going to be just a little bit lower. So now I've drawn my 3 points and I can draw a triangle. So if we want to figure out if this triangle is right angled, we're going to have to figure out how long each of the sides are of this triangle. So I'm going to start off with the easiest one, which is this line here that goes from B to C. The reason it's the easiest is because notice that they both have the same x coordinate, right? So on a coordinate plane, that would mean they're right on top of each other. So vertically thin, we don't need to worry about the x coordinates because they're 3 and 3, but they are a distance of 5 because 5 from 0 is 5 spaces. So this is 5 units. Now, to figure out what the distance is between A and C, so I'm just going to draw kind of like these dashed lines to kind of show if this was a right angled triangle to help visualize this problem a little bit better. So from now, I can think to myself, well, how far is the horizontal distance between my A and my C? So how far is this distance here? Well, if the x coordinate is 1 on the A and 3 on the C, well, how far away is 1 and 3 from each other? Well, they're 2 units away, so this is 2. And then I do the exact same thing for the y coordinates. How far away is 1 and 0? Well, that will be 1. So now I have my right angled triangle. So I can do a squared plus b squared is equal to c squared. And then I have 1 squared plus 2 squared is equal to c squared. And I get 1 plus 4 is equal to c squared. So then I get 5 is equal to c squared. But I want to know what c is. But 5 isn't a perfect square. So I know whatever I do, if I square root both sides, I'm going to get a decimal number, right? So what we can do is just leave it as the square root. It makes it the most accurate number that we have. So I'm just going to write that c is equal to the square root of 5. All right. Now, looking at the line from A to B. Again, I'm going to do the exact same thing. I'm going to do these little dashed lines so I can kind of see that it's a right angle triangle. And now I can find out what is my horizontal distance. Well, the x-coordinate on A is 1 and the x-coordinate on B is 3. So the difference between 3 and 1 is 2. So this distance here is 2. And then the y-coordinates, or my vertical distance, so B has a y-coordinate of 5 and A has a y-coordinate of 1. Well, how far away are the points 5 and 1? Well, they're 4 away from each other. So now I have this other right angled triangle. Again, I can do a squared plus b squared is equal to c squared. My A I can say is 2 squared plus 4 squared is equal to c squared. Now I have 4 plus 16 is equal to c squared. And then I have 20 is equal to c squared. So again, I can take the square root from both sides so I can get what c is equal to. Now c is equal to the square root of 20. Now I could write the decimal out, but again, it would be a lot more accurate to just leave it as the square root of 20. So we'll leave it at that. So this side here is the square root of 20. So now our triangle finally has all 3 of its sides. So now we can do the test. Does a squared plus b squared is equal to c squared? So we now can do our formula again. A squared plus b squared is equal to c squared. Now remember, we have to figure out what the longest side is, right? So if we look at this problem. We could use a calculator to just figure out what the root of 20 is and the root of 5 is so that we can know approximately how big that is and know which side is the longest. Or we can also know that 5 units, well, to get 5 units, we would have to do the square root of 25. So we can now look at the numbers underneath the square root sign. And the number that has the biggest is going to be the one with the largest side. So we know that then the 5 units is the longest side. So we can now do the square root of 20, but that's squared, plus the square root of 5, but that's squared, is equal to 5 squared. So now the reason we kept it as the square root for our answers here and here is because the square root of 20, but then if I square it, it undoes it. So what I'm left with is just 20. And then the same thing for here. The square root of 5, but I square it, gives me 5. And then is equal to 5 squared is 25. And then 20 plus 5 is 25. And I get 25 is equal to 25. Both sides of the equation are equal. And therefore, this does make a right-angled triangle. Whew. That might have been the longest example I have ever had to do for you guys. I am so sorry, but it is good because at least we are practicing finding the distance between 2 points again. So let's do number 3, and we want to figure out if the points form a right angle triangle. But for number 3, let's give ourselves that little help of putting a graph and that coordinate plane so that it's easier for us to visualize. And then for number 4, let's try to do this one without having the graph in front of us. All right, good luck with these two and have a fantastic day. And I will see you guys in the next video.